Is it linear? Identifying linear functions from graphs, tables, equations, and situations. We'll start with some terminology. A linear function has a constant rate of change. The rate of change of a linear function is found by dividing the difference of two outputs by the difference of their respective inputs. The graph of a linear function will be a straight line, a non-vertical straight line. In the table of a linear function, the change in y values over the change in corresponding x values will be constant. And the equation of a linear function can be written in the form y equals mx plus b. Now we'll look at some graphs and we'll decide which of these graphs are linear functions. Linear functions can be continuous or discrete. So we're looking for graphs where it is a straight line and it has a constant rate of change. So there are three linear functions here. The one on the bottom left is not linear because part of the graph has a negative rate of change and the other has a positive rate of change. So it's not constant. Now we'll go on to tables. We're told to identify the linear functions. Let's consider in the first table, as x increases by 1, y is not increasing by the same amount. Therefore, the rate of change is not constant and it's not linear. In the middle table, as x increases by 1, y increases by 4. This is linear. In the last table, as x increases by 5, y increases by 7. This is linear. So linear functions, the tables will show a constant rate of change. Now we'll look at equations and determine which of these equations represents a linear function. Let's use Desmos.com to graph them. I've got some screenshots of these graphs for you to consider. And remember, a linear function is one which is a straight line, and there are two linear functions, and both of them, you'll notice, has y to the first power and x to the first power. So when we're looking at equations of linear functions, x will be to the first power. Now finally, situations. Let's look at the top left one. Margaret planted seeds. The first week it grew 2 inches. The next week it grew 3 inches. The next week it grew 5 inches. That is not a constant rate of change. It is not linear. Bottom left problem. Cindy bought a box of chocolates with 36 candies inside. Each day she ate 2 chocolates. So this is showing a negative constant rate of change. It's linear. A restaurant charges $10 for the first burger and $8 for each additional burger that a table orders. Even though the first burger costs more money, because each additional burger costs the $8, this is linear. The McNaughton boys rake leaves for extra money. Their rakes cost them $50 to purchase. They earn $15 for each lawn raked. This is a linear situation. Now let's look at some nonlinear representations. Let's look at the graph. That's the easiest one to tell it's nonlinear because the function is not at a constant rate. Although it's always decreasing, it's not a straight line, so it's nonlinear. Secondly, in the equation, notice the x is not to the first power. That's why this equation is not linear. And now in the situation, the rate of change that is described is not constant. Mrs. Jones deposits $100 into her bank account on January 1st. On February 1st, she deposits $250. On March 1st, she deposits $500. On April 1st, she deposits $100. Notice this is not a constant rate of change, so it's not a linear representation.